You know the promise of self-driving cars, right? Fewer accidents, less traffic, getting your time back. But it feels like that future is always just around the corner. So what's the missing piece? What's it going to take to finally unlock this whole thing for everyone? Well, what if the answer is the same kind of tech that powers something like ChatGPT? That's what we're going to dig into here. This idea that a massive AI, what's known as a foundation model, could be the big breakthrough that finally cracks the code for self-driving cars. But first, let's just step back. Why is this problem so incredibly hard to solve in the first place? I mean, we've had cars that can handle basic highway driving for years. The real challenge, the thing that has had engineers scratching their heads for more than a decade, is way, way more complicated.
And that challenge, it has a name, the long tail problem. This is the absolute core issue keeping self-driving cars stuck in limited test zones. It's not about the normal, everyday 99% of driving. Nope, it's all about handling that chaotic, unpredictable 1% of stuff that happens on the road.
So what does this long tail actually look like in the real world? Well, it's that deer that suddenly jumps out in front of you, or a construction worker waving you through a stop sign. It's about understanding all those unwritten rules of the road, like how drivers in some places pull onto the shoulder to let you pass. It's about making human-like judgments, like knowing it's actually safer to cross a solid line for a second to avoid a huge pothole. You just can't write a pre-programmed rule for every single one of those possibilities. There are infinite. And this is where a totally new approach comes in, the foundation model. So instead of trying to write a rule for everything, the idea here is to build a massive neural network, feed it just an insane amount of driving data, and let it learn generalized skills, kind of like how a person learns to drive. And I mean, this is a huge shift in thinking. The old way was all about programming strict rules, right? Like, if you see a red light, then you stop. The new way is about showing the AI millions of examples of different intersections and letting it generalize the concept of how to navigate them safely. It's the difference between just following a command and actually truly learning a skill.
You can actually think about it a lot like how a language model like ChatGPT works. An LLM, a large language model, it takes in text, turns it all into these digital tokens, and then just predicts the next most likely word. Well, a large motion model, or LMM, does the exact same thing, but for driving. It takes in all the sensor data, tokenizes the real world around it, and then predicts the safest and most efficient driving move to make next.
So how does this actually work second by second in the car? Well, first, the car perceives the world with its cameras and sensors. Then the AI tokenizes that whole complex scene. It turns it into a simplified digital language it can understand. And finally, it predicts the best thing to do next. It's this constant, super fast loop. Perceive, tokenize, predict. Over and over and over. And all of this leads to the big, really optimistic theory that's kind of driving the whole industry right now. The belief is that scale is the solution. The idea is that if you can just build a model that's big enough and feed it enough high-quality data, you can basically create an AI that's smart enough to handle anything the road can possibly throw at it. Yeah, but it's just not that simple. Critics are quick to point out some really serious hurdles. For one, you get diminishing returns. Every new billion miles of data you add gives you smaller and smaller improvements. The AI can also hallucinate, making bizarre, unsafe decisions for no obvious reason. And then there's the black box problem. If we can't explain why the AI made a certain choice, how can we ever really prove that it's safe? And finally, when you try to update the model with new info, it can sometimes forget critical lessons it had already learned. That's a big one. So, because of all these challenges, companies are basically splitting into 3 different camps on how to build this thing. Some are using a stacked model, where they kind of bolt together a bunch of smaller systems. Others are trying to run one big model right there in the car, but they keep hitting the limits of the onboard computer. And then there's the cloud-based approach, where a truly massive model is trained remotely. This is the big bet that companies like Xpeng are making. But it has its own risks, right? Like network stability and, of course, data security. And that third option, the huge cloud model, has kicked off what is basically an all-out war. Not on the roads, though, in the data centers. The new race is a battle for just sheer, raw computing power. And the scale of this arms race is just mind-boggling. I mean, you've got players like Huawei and Xpeng targeting massive amounts of computing power. But Tesla's goal of 100 FLOPS is it's astronomical. That's a level of power that's pretty much equivalent to all the other Chinese car manufacturers combined. This isn't just a tech war, it's a war of money. Okay, so that's the theory and the big tech race. But what's actually happening on our streets today? Well, in the US, Alphabet's Waymo is the undisputed leader. They're providing nearly 500,000 paid rides every single week. This isn't some test anymore. It's a real functioning business.
And if you look globally, the story gets even bigger. The volume leader is actually China's Baidu with their Apollo Go service. They've already completed over 17 million rides across 22 different cities. So while some companies are focused on building that future capacity, others are out there delivering at a massive scale today. But then you've got Tesla, and they're playing a totally different game. They might be lagging in commercial rides, but their huge advantage is data. Their massive fleet of consumer cars, just driving around every day, has collected over 10 times billion miles of real-world driving data. And all that data is the fuel that feeds their massive computing engine. So the big question is, does all that data actually translate to safety? And this is where the story gets really complicated. Recent reports show Waymo's fleet has an injury crash rate that's 90% lower than the average human driver. That's huge. But in contrast, early data from Tesla's driverless pilot program in Austin showed a crash rate that was significantly higher than humans. It is a really stark difference between a system that's proven but geographically limited and a much more ambitious one that's clearly still a work in progress.
So when you put it all together, what does it really take to crack this nut? It seems pretty clear the answer isn't some single silver bullet. It's a combination of everything we've talked about. A powerful, data-hungry foundation model, for sure, but also a transparent safety system to act as a guardrail. The ability to actually explain the AI's decisions to get it out of that black box. And of course, the massive, massive investment needed to power the whole thing.
Which leaves us with one final big question. As this whole tech race barrels forward, is the biggest remaining obstacle purely technical? Just a bigger model or more data? Or is the highest hurdle something else entirely? Actually earning our collective trust to finally let go of the wheel.